this is going to be the spec for the unit circle, or the unit circle definition of trig identities. Maybe we'll just call it unit circle. And the general idea here is to just make sure that students understand the unit circle definition of the trig ratios or the trig function. So what we're going to do is just ask them what the sine, cosine, or tangent of an angle is, and it can be in degrees or radians. So over here, so let's say an example would be, what is the cosine of 30 degrees? So we say the cosine of 30 degrees is equal to what? And over here, so this right here can be sine, cosine, or tangent. And in terms of the angles themselves, it could be, so this could have also been written as, what is that, pi over 6 radians. So we would just write pi over 6. Or you could, so radians or degrees. And then, just so we can actually solve for the angles, they can't just be any arbitrary angles. They have to be multiples. Let me write in this purple. Multiples of, if we do it in degrees, 30 degrees and 45 degrees. Because those are the only ones that you can actually figure out straight from the unit circle using your knowledge of either, just the Pythagorean theorem, or 30, 60, 90 triangles, or 45, 45, 90 triangles. So we're going to give them, cosine of 30 degrees is equal to what? This is what they should see. And with that, they should see an actual drawing of a unit circle. So over here, there'll be an actual drawing of a unit circle. So there will be an actual drawing of a unit circle, just like that. And we'll actually draw out the 30 degrees. So maybe this right here is the baseline of the unit circle. Maybe draw it dotted like that. And then we want to highlight the actual 30-degree point. So you actually want to highlight the 30 degrees. So we'll say this is right here, the 30 degrees. Now, and then the choices are just going to be all of the different possibilities. The correct choice right here would be square root of 3 over 2. So the correct, let me do this in the black color. The correct choice here is, I'll make it, this one is the correct, square root of 3 over 2. But the other choices, maybe it's 1/2, maybe it's square root of 2 over 2. A lot of the typical ones you see, maybe negative 1/2, maybe, I don't know, we could put in a negative square root of 2 over 2. And obviously, you could add more than, these other possible incorrect answers might be negative square root of 3 over 2. All of the different ones that come up when you do unit circle problems. So the first hint, when someone clicks hint, the first thing they should be reminded of, so the hint number 1, right when they click it the first time, and they don't want to start see the bullet point. I'm just going to do the bullet point here so that you realize that that is the first hint. You say, the cosine of the angle is where the unit radius, this thing here, the unit radius is, let me actually, is not where, is the x coordinate, of where, or let me say not of where the unit radius, I'll just say radius, where the radius intersects the unit circle. And we could say, we could even, right when that gets clicked, we can highlight this point right there and show that it's the coordinates of that point are the cosine of x, sine of x. We obviously want to make this picture a little bit bigger so that we could potentially write that there. Now, if the student still doesn't know how to do it, they'll click hint again. And they'll get this hint. They'll say, well, think about the right triangle. Think about the right triangle with the radius as its hypotenuse. with the radius as its hypotenuse. Hypotenuse. And then we'll just draw it. So right when they click that for that second hint, they'll actually get the drawing. So we'll actually draw that triangle, and we'll even show it's a right triangle right there. They'll see that very clearly. And then you say, if they still don't know how to do it, you say this is a 30, 60, 90 triangle. This is a 30, 60, 90 triangle. And the x-coordinate of the intersection, I guess we could say, the x-coordinate where the radius intersects the unit circle is equal to the length of the side opposite the 60-degree side, the 60-degree angle. And so we would draw. And here we might want to do a little color coding if it's not too difficult. We could say so we say is equal to the length. So the length of the side opposite the 60 angle. So is equal to the length of the side opposite the 60 angle. We might want to color code that and color code this length right there so that that side is what we are talking about. And then if they still don't know how to do it, the last hint says that this is a actually we already said this is a 30, 60, 90 triangle. We just say, because it's a 30, 60, 90 triangle, or we could play with the wording a little bit. That side is equal to square root of 3 over 2 times the hypotenuse, which is 1. So cosine of 30 degrees is equal to square root of 3 over 2. And we might want to actually, just so it make it clear, we might want to throw in here from our knowledge of 30, 60, 90 triangles. And we've already made a module on that. From our knowledge of 30, 60, 90 triangles. And you'll want to do the same with sine or tangent. And of course, with the tangent, and it'll be a little interesting with tangent of 90 degrees or of negative 90 degrees or of 270 degrees. And we could put choices like infinity or negative infinity or things like that, or undefined. However you want to do it, whatever makes sense. Or you can even leave those out in the initial rev, and we can add them later.